In the name of Almighty God, I'm Mahsa Sankoshi, and today I want to talk about high voltage insulator. High voltage electrical insulators are vital components in electrical power transmission and distribution systems. Isolators are devices designed to withstand high electrical voltage and isolate the electrical conductor from the tower support. In this simulation, we will explore the main features of high voltage insulator. The first question is what are high voltage insulators? High voltage insulators are devices used to isolate the electrical conductors from the tower and the ground. These devices are designed to withstand high electrical voltage and hold the electrical conductor in position. The insulators are used in high voltage power transmission and distribution lines. The next is types of high voltage insulators. There are several types of high voltage insulators, each with specific characteristics and applications. Some of the most common types include the first one is uh, porcelain insulators. Ceramic or porcelain insulators are most commonly used on voltage lines from 11 kilovolt to 400 kilovolt. These insulators are made of fired clay and have high mechanical and dielectric strength. The next is polymeric insulators. With the innovative polymer insulators, all the most demanding requirements are met by offering a wide range of products. The positive features of these solutions facilitate assembly and maintenance, save time and cost, and add value to the product of the highest quality. The next type is glass insulators. Glass insulators are the oldest and most common insulators in transmission and distribution lines. These insulators are made of tempered glass and are used on voltage line up to 33 kilovolt. The next type is composite insulators. Composite insulators are made of glass fiber and epoxy resin. These insulators have high mechanical and dielectric strength and are used in voltage line up to 800 kilovolt. And what are the characteristics of high voltage insulators? High voltage insulators have several characteristics that make them suitable for use in electrical power transmission and distribution systems. Some of the main characteristics include the first one is dielectric strength. Dielectric strength is the ability of an insulator to resist electrical breakdown. High voltage insulators must have a high dielectric strength to withstand high electrical voltage. The next is mechanical strength. High voltage insulators must also have high mechanical strength to withstand electrical conductor loading and extreme weather conditions. The next one is resistance to contamination. High voltage insulators are exposed to extreme environmental conditions, including contamination by dust, snow, ice, and rain. Insulators must have a high resistance to contamination to maintain their dielectric efficiency. The next one is physical dimensions. The physical dimensions of high voltage insulators must be precisely designed to withstand the load of the electrical conductor and meet the space requirements in the tower. The next one is thermal stability. Thermal stability is the ability of an insulator to withstand the high temperatures generated by the electrical current. High voltage insulators must have high thermal stability to prevent the formation and failure of the material. The next one is electrical insulation. High voltage insulators must have a high electrical insulating capability to prevent current leakage and maintain the integrity of the electrical system. The next is durability. High voltage insulators must have a long service life and be resistant to environmental degradation and mechanical fatigue. The next characteristic is ease of installation and maintenance. High voltage insulators should be easy to install and maintain, which reduces the time and cost associated with the installation and maintenance of electrical power transmission and distribution systems. The next is high voltage insulator design considerations. The choice of high voltage insulator type and design depends on several factors such as the line voltage electrical conductor, loading, environmental conditions, and tower design specifications. Some important high voltage insulator design considerations include: the first one is creepage distance. Creepage distance is the distance along the surface of the insulator required to prevent arcing. The creepage distance must be large enough to withstand the line voltage and prevent arcing. The next is minimum bending radius. The minimum bend radius is the minimum radius that can be applied to the insulator surface without damping the material. The minimum bend radius must be larger than the line bend radius to prevent deformation and failure of the insulator. The next is isolator surface design. The insulator surface design must be designed to prevent the accumulation of contaminations and allow for self-cleaning to maintain the dielectric efficiency of the insulator. The next one is insulation materials. Insulation materials should be selected based on their dielectric, mechanical, and thermal properties. Common insulation materials include glass, porcelain, and glass fiber composites. High voltage insulators are vital components in electrical power transmission and distribution systems. The proper selection of the insulator type and design depends on several factors including line voltage, electrical conductor, loading, and environmental conditions. The main characteristics of high voltage insulators include dielectric and mechanical strength, resistance to contamination, thermal stability, electrical insulation, durability, and ease of installation and maintenance. And the important things about high voltage insulator. What is a high voltage insulator? A high voltage insulator is a device used to isolate the electrical conductors from the tower and ground in high voltage electrical power transmission and distribution systems. Why are high voltage insulators used in electrical power transmission and distribution systems? Actually, high voltage insulators are used to withstand high electrical voltage and hold the electrical conductor in position, preventing current leakage and arcing. What are the most common types of high voltage insulators? The most common types of high voltage insulators are porcelain, glass, silicone, and composite insulators. At points, we recommend ceramic and polymer insulator. What are the main characteristics of high voltage insulator? The main characteristics of high voltage insulators include dielectric and mechanical strength, resistance to contamination, thermal stability, electrical insulation, durability, and ease of installation and maintenance. What design considerations are important for high voltage insulator? Some important design considerations for high voltage insulators include creepage distance, minimum bend radius, insulator surface design, and insulation materials. What is a low voltage insulator? To get all the information from the low voltage insulator, I will uh, describe it later after this topic. Insulators are essential elements in industry as they protect workers and machinery from potential electrical accident. In this simulation, we will explore specific applications of insulators in the different industrial sectors and their importance in ensuring the safety and proper functioning of electrical installations. What are insulators and why are they important? Electrical insulators are materials that are used to prevent the passage of electrical current in certain locations, either to protect people from potential electric shocks or to protect machinery from short circuit. Insulators are a key element in any electrical installation as without them electrical accidents can be common and dangerous. Insulator in industry. Specific applications in different sectors, electrical sector. Isolators are essential in the electrical sector as they enable the safe and efficient transmission of electrical energy. Insulators are used in transmission towers, poles, or transformers and are made of different materials such as glass, porcelain, ceramic, and polymers. The railway sector. In the railway sector, insulators are used to prevent short circuit in the power lines that feed the trains. Isolators are also used in traffic signals to ensure that there is no electrical interference that could affect communication between trains and control center. Construction sector. In the construction industry, insulators are used to protect workers from potential electric shocks on scaffolding and construction equipment. Insulators are used on power tools such as drills and saws to prevent electric current from passing to the user. The next one is automotive sector. In the automotive sector, insulators are used to protect electrical components in vehicles from short circuits. Isolators are used in ignition systems, lights, and electric motors to ensure proper operation and prevent potential electrical accidents. And what are the types of insulators? Porcelain insulator. Porcelain insulators are the most common type of insulators in high voltage lines and are used in transmission towers and poles. Porcelain insulators are resistant to heat and wear and have a long service life. And what about glass insulators? Glass insulators are used in low and medium voltage lines as well as in transformers. Glass insulators are weather and corrosion resistant and are very efficient in preventing short circuit. The next one is polymer insulators. Polymer insulators are a more modern alternative to porcelain and glass insulators. They are lighter and more resistant to breakage and vandalism, making them ideal for use in locations where there is a risk of damage to insulators, such as in urban areas. Maintenance of insulators. Regular maintenance of insulators is important to ensure their proper functioning and to prevent potential failures in electrical installation. Maintenance should include cleaning the insulators and checking their physical condition. As we have seen, insulators are essential elements in industry and have a wide variety of applications in different sectors. It is important to choose the right type of isolators for each application and to carry out regular maintenance to ensure that they function correctly. Isolators are a fundamental part of any electrical installation and their correct use can prevent potential electrical accidents. Why are insulators important in industry? Isolators are important in industry because they protect workers and machinery from potential electric accidents. What are the different types of insulators? The different types of insulators including porcelain, glass and polymer insulators. And where are porcelain insulator used? Porcelain insulator are used in transmission towers and high voltage poles. And what is the importance of insulator maintenance? Regular maintenance of insulators is important to ensure their proper functioning and to prevent possible failures in electrical installations. What are the advantages for electrical insulators are key elements in power distribution and transmission infrastructure, designed to support and electrically insulate conductors from supporting structures and earth. Their choice depends on several factors, including the voltage level of the line, environmental conditions, and the type of installation. And what are the types of electrical insulator installation? There are several types of insulators, each with a specific characteristics for their application. Suspension isolators. Insulators are critical components in electric power transmission and distribution infrastructure designed to support the weight of the overhead lines while maintaining a safe separation between supporting structures and energized conductors. These insulators are characterized by their ability to withstand not only the weight of the conductor but also the additional loads caused by wind, ice buildup, and thermal variations. And what are the main characteristics? Suspension insulator typically consists of an assembly of ceramic or porcelain insulator or glass discs that are connected in a series by metal fitting. Each disk is designed to withstand a fraction of the total voltage, and the number of disks in an assembly is determined by the voltage level of the transmission line. These insulators are especially useful on high voltage lines where the electrical isolation distance required is considerable. And what are the advantages? One of the main advantages of suspension isolators is their flexibility. As they are suspended, they can be moved to absorb dynamic loads caused by wind or conductor oscillations, reducing the risk of fatigue and failure. In addition, their modular design allows easy replacement of individual disks without the need to replace the entire assembly, facilitating maintenance and reducing operating costs. And what are the applications? Suspension isolators are predominantly used in high voltage transmission lines where efficiency and safety are paramount. They are especially valuable in regions with extreme environmental conditions, such as areas with high salinity, industrial pollution, or where the risk of icing is significant. In these conditions, suspension isolators offer a reliable and durable solution to maintain the integrity and performance of the electrical system. And what about maintenance and testing? Maintenance of suspension isolators involves regular visual inspections, cleaning to remove contaminants that may compromise their performance, and electrical testing to assess their condition. Testing may include measuring insulation resistance and verifying the mechanical integrity of the assemblies. And what about the selection considerations? When selecting suspension insulators, it is important to consider the voltage level of the line, the expected environmental conditions, and the maximum mechanical load. It is also crucial to choose suitable materials for disk and hardware, ensuring optimum resistance to corrosion, wear, and environmental influences. Suspension insulators play an essential role in the safety and efficiency of power transmission networks. Their design enables efficient distribution of electrical and mechanical loads, guaranteeing the reliability of the power supply even under the challenging conditions. Proper selection, regular maintenance, and adaptation to local conditions are key to maximizing their lifetime and performance. And the support or pole isolators. Support insulators, also known as pole insulators, are critical components in the design and operating of electrical substations and power distribution facilities. They are designed to support and electrically insulate conductors and other electrical components of support structures in ensuring the safe and efficient transmission of electrical power. And what is the main features and functions? Support insulators are typically made of porcelain, glass, or composite materials and are designed to withstand the vertical mechanical loads imposed by conductors and electrical equipment they support. Unlike suspension insulators, support insulators are designed to withstand compressive loads and can have various shapes such as cylindrical, disc-shaped, or rectangular, depending on their specific applications. And what are the advantages and applications? A significant advantage of support insulators is their ability to withstand high mechanical loads while providing a high degree of electrical isolation. This makes them ideal for use in electrical substances where they must withstand not only the weight of electrical equipment but also the dynamic forces that can be generated during normal operations or fault conditions. In addition, support insulators are critical in the configuration of substantial equipment such as circuit breakers, transformers, and disconnectors, ensuring that these components remain electrically isolated from airs and from each other. This is crucial to prevent short circuits and other types of electrical faults that could compromise the safety and efficiency of the electrical system. And the maintenance and design considerations. Maintenance of support insulators involves regular inspections for cracks, surface contamination, and material wear. Periodic Cleaning and electrical testing are also essential to ensure their optimal performance and prolong their service life. When selecting support insulators, it is important to consider the stress level of the system, environmental conditions such as contamination and humidity, and expected mechanical loads, choosing the right material, porcelain, glass, or composites. And the right design is crucial to meet performance and durability requirements. Supporting insulators play a vital role in the safety and efficiency of distribution networks and electrical substations. Their design and construction must be carefully considered to withstand the operating and environmental conditions to which they will be subjected. Proper maintenance and careful selection of these components are essential to ensure reliability and safety in the supply of electrical power. And what about earthing isolators? Earthing insulators are key components in electrical protection systems specifically designed to ensure a safe path for the flow of electrical currents to earth in the event of fault or for maintenance operation. These isolators play a vital role in preventing accidents and protecting equipment and people against electric shock. And what about function and principle of operation? The main function of earthing insulators is to facilitate the earthing of parts of an electrical system which are not normally energized, but which may become energized in the event of a fault. This includes the frame of electrical machines, equipment housing, and supporting metallic structures, among others. The correct installation of these insulators ensures that any leakage or fault current is effectively directed to earth, minimizing the risk of electrocution or damage to equipment. And what are the types and materials? There are several types of grounding insulators, including solid insulators, which are typically made of materials such as porcelain or polymer insulator, and are designed to withstand harsh environmental conditions and high electrical voltage. The material used must have a high dielectric strength and be able to withstand fault currents without deterioration. And what are the advantages of their use? The implementation of grounding insulators offer multiple advantages such as surge protection and prevention of equipment damage and personal injury. In addition, they help maintain the integrity of electrical systems, allowing for safer and more reliable operation. Proper selection and installation of these insulators are critical to comply with electrical safety regulations and to ensure optimum protection against electrical shock. Selection and installation considerations. The selection of grounding insulators should be based on the voltage level of the system, the expected environmental conditions, and the specific requirements of the application. It is crucial to consider the insulator's ability to withstand fault currents and its compatibility with existing grounding systems. Installation should be carried out in accordance with relevant best practice and standards, ensuring an effective and safe connection to the grounding system. And what about the maintenance and testing? Maintenance of earthing insulators includes regular visual inspections for damage or deterioration, as well as insulation resistance tests to verify their effectiveness. Periodic testing is essential to ensure that the grounding system remains capable of effectively handling fault currents. Grounding insulators are essential components for the safety and efficiency of electrical systems, providing an effective means of controlling fault currents and protecting both people and equipment. Proper selection, correct installation, and regular maintenance are key to maximizing their performance and ensuring a safe operating environment. Each type of insulator plays a crucial role in the safety and efficiency of electrical networks. The right choice of insulator type and material adapted to the specific conditions of each project. It is essential to ensure the durability, performance, and safety of the electrical system. As technology advances, insulator materials and designs continue to evolve, offering more efficient and resistant solutions to the demands of modern power transmission and distribution networks. The performance of electrical insulators is critical to ensure the efficiency and safety of electrical power transmission and distribution. Several factors can influence their effectiveness, compromising the integrity of the electrical system. Understanding these factors is essential for preventive maintenance and proper selection of insulators. And what factors affect the performance of an electrical insulator? Among the most significant are materials and design. The materials used in the manufacture of insulators, as well as their design, are key determinants of their performance. Porcelains and glass have traditionally been the most commonly used materials, although in recent decades polymer composites have gained popularity due to their resistance to contamination and lighter weight. Proper design is also crucial to maximize insulation capacity and minimize the effects of surface contamination. And what about the environmental conditions? Environmental conditions play a crucial role in the performance of insulators. Contamination, whether in the form of dust, sea salt, or industrial waste, can deposit on the surface of insulator, reducing their effectiveness, and moisture combined with contamination can lead to the formation of a conductive layer on the insulator, increasing the risk of surface electrical discharge. In addition, extreme temperatures and exposure to ultraviolet radiation can affect the integrity of the material over time. And the electrical overloads. Electrical surge caused by peak demand, atmospheric discharge, or system failure can subject insulators to voltage higher than they are designed to handle. This can cause internal or external damage, reducing their service life and efficiency. And what about the aging and deterioration? Over time, all insulators undergo a process of aging and deterioration. Continued exposure to the environmental and electrical factors mentioned above can accelerate this process, compressing the insulator's ability to function effectively. Material degradation, whether through erosion, cracking, or loss of dielectric properties, is a critical aspect that must be monitored. And the maintenance and cleaning. Lack of proper and regular maintenance can exacerbate the negative effects of an environmental and overload factors. Periodic cleaning of insulator is essential in areas with high contamination, as is inspection for signs of wear or damage. The performance of electrical insulators can be significantly affected by a combination of factors related to insulators, materials, and design, environmental conditions, electrical overloads, and natural aging of components. A true understanding of these factors is critical to implementing effective maintenance strategies and to the power selection of insulators best suited to the specific needs of each electrical applications. Electrical insulators are fundamental elements in any electrical system, as they are responsible for separating the electrical conductors from the rest of the elements that make up the circuit. In this way, they prevent electricity from escaping and causing damage to or accidents. In the case of low voltage insulators, they fulfill this function in systems that work with voltage of less than 1000 volts. The main characteristics of these elements are detailed below. And what are the low voltage insulators? Low voltage insulators are devices used to separate electrical conductors from the rest of the circuit elements in systems operating with voltage below 1000 volts. These elements can be made of various materials such as glass, ceramic, porcelain, epoxy resins, among others. Their main function is to prevent electricity from escaping and causing damage or accident. Main characteristics of low voltage insulators, dielectric storage. Dielectric storage is one of the key characteristics of low voltage insulator. This property refers to the ability of a material to resist the electric current trying to pass through it. In the case of insulators, this resistance must be high enough to prevent electricity from passing through them. And the next one is dielectric rigidity. Dielectric rigidity is another important property of low voltage insulators. It refers to the material's ability to withstand high voltage without undergoing electrical discharge. For insulators, this rigidity must be high enough to support the voltage of the circuit in which they are used. And the next characteristic is mechanical strength. Mechanical strength is another crucial characteristic of low voltage insulators. This property refers to the ability of a material to withstand physical stresses such as impacts, vibrations, temperature changes, among others. For insulators, this strength must be high enough to endure the environmental conditions in which they are used. And the next characteristic is corrosion resistance. Corrosion resistance is another significant property of low voltage insulators. It refers to the ability of a material to resist the action of chemical or environmental. For insulators, this resistance must be high enough to withstand the environmental condition in which they are used. And the next characteristic is easy installation and maintenance. Low voltage insulators should be easy to install and maintain. This is important to reduce the time and cost of installation and maintenance of the electrical system in which they are used. The next is types of low voltage insulator. There are different types of low voltage insulators depending on the material they are made of and their shape. Some of the most common types include porcelain or ceramic insulator. Porcelain or ceramic insulators are a common type of low voltage insulators. These insulators consist of a porcelain body attached to a metal base. The advantage of a porcelain insulators is their high dielectric rigidity and resistance to corrosion, sun, and wind effects. However, they are more fragile than glass insulators and can break easily. The next one is silicone insulators. Silicone or polymer insulators are another type of low voltage insulators. These consist of a silicone body attached to a metal base. The advantage of silicone insulators is their high resistance to ultraviolet rays and aging due to the sun exposure and weather conditions. They are also very lightweight and have high mechanical strength. And what about the glass insulators? Glass insulators are one of the most common types of low voltage insulators. These consist of a glass tube attached to a metal or porcelain base. The advantage of a glass insulator is their high dielectric strength and durability. They are also resistant to corrosion and the effect of sun and wind. The next one is epoxy resin insulators. Epoxy resin insulators are another type of low voltage insulators. This consists of an epoxy resin body attached to a metal base. The advantage of epoxy resin insulators is their high resistance to corrosion and the effect of sun and wind. They have high mechanical strength and are lighter than glass or porcelain insulators. How to choose the right insulator? To choose the right insulator for an electrical system, several factors should be considered, such as the type of current used, the load the insulator will support, the environment in which it will be used, among others. It is important that in the insulator has the appropriate dielectric strength and rigidity for the electrical system in which it will be used. Low voltage insulators are essential elements in any electrical system operating with voltage below 1000 volts. These elements have different characteristics such as dielectric strength, dielectric rigidity, mechanical strength, and corrosion resistance. Moreover, there are different types of insulators such as glass, porcelain, epoxy resins, and silicone, which can be used depending on the environment in which the electrical system will be used. By choosing the right insulator, the safe and efficient operation of the electrical system can be used. And what is the dielectric exchange? Dielectric exchange is the ability of material to resist the electric current attempting to pass through it. And what is the dielectric rigidity? Dielectric rigidity is the ability of material to withstand high voltage without experiencing electrical discharge. And what types of low voltage insulators are there? There are different types of low voltage insulators such as glass, porcelain, epoxy resin, and silicone. And how is the right insulator chosen? To choose the right insulator, several factors should be considered, including the type of current used, the load the insulator will be support, and the environment in which it will be used. Why is insulation important in an electrical system? Insulation is crucial in an electrical system to prevent electricity from escaping and causing damage or accident, ensuring the system operates safely and efficiently. And what is a high voltage insulator? To get all the information about high voltage insulator, I have mentioned in the section of simulation. This example demonstrates how to use the electrostatic interface to calculate the surface electric field of a typical high voltage insulators. It is shown that the inhomogeneity and the maximum of the surface electric field are greatly reduced with the installation of the grading rings. In this way, the high voltage insulators is able to withstand a higher voltage. And here you can see the components and electrostatic as a physical module and the materials that I have used, for example, core rod and weather shed. And you can see the electric potential revolve geometry and also with grading rings, electric fields based on volt per meter, electric potential revolve geometry, and you can see that the pole has the minimum and maximum sort of electric potential, electric potential without grading rings. And the last one is tangential electric, that you can see that how much is fluctuating based on tangential electric field in Z components. Thank you so much for watching my tutorial video until the end, and also you can download this simulation from my github.com/mahsa script.